So everyone knows I'm Destry Atkinson from Loma Building Technologies. Today we're going to be talking to Innovent about natatorium and pool design. We're going to go ahead and start a slide presentation, and we'll just let Jeff take it from here.
All right. Give me 1 second here. Share and all right. Is that the right screen or not?
Yep, looks good.
All right, sounds good. Well, thank you all for taking the time to spend some time with us here this morning. As Destry had said, my name is Jeff Peterson. I'm going to give you guys a little bit of an introduction on Innovent's approach to indoor pool spaces and kind of what the values are of it, and give you a little bit of an introduction to the application and some things that you want to keep in mind when you're designing systems for those. So give you a little bit of a background on myself. So I'm the area sales manager for Long from Innovent. So when you contact one of your sales contacts from Long and say, hey, we need a design on something from Innovent, I'm the guy that they contact at the factory who helps them out and puts together quotes and those types of things. You know, when everything gets back to normal and we're traveling again, I'll also be the guy that shows up at your office, hopefully, to do lunch and learns and you know, sales calls and that kind of stuff. So I look forward to that happening here in the near future. I've been with the company for a little over 8 years now. Before that, I was a local sales engineer with the Train company. My background educationally, I went to Iowa State. So if there are any Cyclones on the call, great. I do have a personal connection to the Salt Lake City area, by the way. I did a semester of exchange at the University of Utah, and I worked at the Pie Pizzeria near the university there. So in case anybody was there in the 2003 timeframe, I probably served you up a pizza. Innovent is a custom air handler manufacturer, and while we have a unique and very value-added approach to how we do pool units, we also do really anything where energy recovery is involved, or there's a need for a custom air handler, office buildings, high schools, higher ed, you know, all sorts of applications, and focuses on energy recovery. Some of the things that set us apart, though, is we can do custom packaged refrigeration. A lot of custom manufacturers don't want to get into that. And we also do packaged custom controls. So if you've got a custom sequence that you're trying to achieve, we can provide that from the factory. A lot of other manufacturers don't like to get into the control stuff. So those are some of the things that set us apart. Our installed footprint nationwide over the last 25 years, we've done almost 1,000 pools. And in Long's territory, we've done over 70. Long's actually our strongest territory when it comes to pool projects. So they've been a good partner over the years. Our relative size is about $60 million. So we're in that medium HVAC manufacturer range, not one of the biggest players out there, but we have been around for quite some time. So if you're new to us, you know, welcome, but we've been around for a while. So what do I want to talk about? I'm going to cover some of the application considerations, what's different about a pool space, what are the things that you need to be watching out for, what are the things you need to be designing for, what to keep in mind when you're working on these types of projects. A lot of engineers that we work with, you know, when we talk about pool projects, they say, hey, we see maybe 1 to 2 pool projects every single year. So hold on a second here. I'm gonna adjust this. Sorry about that. So we'll talk about the application considerations. There is a conventional approach on how to do this. There is a you know, kind of an old way that was developed in the 80s and 90s, and that's the mechanical dehumidifier approach. I want to make sure that you guys get familiar with that, and then I'll talk about how our approach is different and kind of what the benefits are of that, and then we'll wrap up. So application considerations. What are some things to keep in mind? You know, the name of the game with a pool project is you've got this large body of warm water in an indoor environment, so you need to dehumidify that space year round. You know, unlike an office space where, you know, your space temperature is going to be in that 70 to 75 degree range and 30 to 50% relative humidity year round. For a pool, your space temperature is usually in the 82 to 84 degree range, right? So the space is at a much higher dry bulb temp. The relative humidity range is 40 to 60%. So we all know that you don't want a space to get too humid, right? You don't want that humidity level to rise above 60. And the reasons are you don't want mold buildup, mildew, and condensation and things like that. But a lot of people don't realize, you also don't want it to get too dry in a space. If your relative humidity gets too low in a pool space, it's going to drive your evaporation rate up. And it can also promote the spread of viruses and things like that. So you want to make sure that you're not over drying those spaces as well. I mentioned the relative humidity in the space, 40 to 60%. The water temperature is usually around 2 degrees cooler than the air temperature. We control to the air temperature because you want to make sure that swimmers that get out of a pool don't get super cold when they're walking around and they're wet, right? You're most concerned about the comfort of the swimmers who are walking around rather than the spectators or the people who are coaching or something like that. But also, if you want to make sure that the water temperature is 2 degrees cooler and that you don't have really cold air in the space. Some customers ask, well, why aren't we controlling to like 70 degrees? If you've got coaches in there, you don't want them to be too hot. And the reason is if you have 70-degree air temp and 80-degree water, the evaporation rate is going to go through the roof. So that's going to really, really drive up the required size of the HVAC equipment. And it's also going to increase the water load. You're going to have to be constantly adding more and more water to that pool. So those are some things to keep in mind. The single biggest consideration is around chloramines, though. And many of you, if you've been involved with any pool projects, chloramines are probably not something new, but it's very important to talk about because it's the most important issue that arises on these projects. Chloramines are what you get when free chlorine that's injected into pool water interacts with organic material, right? So the most pleasant example of that would be sweat from a swimmer or dirt from our skin when we get into the pool or whatever. The chlorine grabs onto that, right? And it neutralizes it, and it disinfects it, which is great, right? That makes the water quality better. It limits the spread of disease and things like that. And then it exits the pool water when it evaporates, which the pool is constantly evaporating. And that's okay, and that's the process that we want to have happen. However, chloramines are highly corrosive, and they're irritants for occupants. So they can cause lung issues, they can cause irritation in eyes, and there's a lot of horror stories out there about chloramines building up to an excessive amount in pool spaces where there's not enough ventilation. And when that happens, buildings can kind of start falling apart structurally. And in some applications, there have been colleges and universities which aren't allowed to hold swim meets anymore because the chloramines have gotten so far out of whack. Many of you probably remember, when you were young, you go on vacation, or if you have families, you go on vacation, you stay in a hotel, and you walk into the lobby and you smell that pool smell, right? And you say, oh, cool, they've got a pool. I don't want to ruin that, childhood memory for you if that's what it is, but that's a really bad sign when you can smell the pool. It means that the chloramines are excessive. It means that they've built up, and that odor associated with them means the pool water chemistry is not really in a great space. So the best pools are the ones that you can't smell. The other considerations that you want to keep in mind are just like maintenance, right? What is the application? What is the space usage? There are things that we want to do a little bit differently when it's a YMCA versus when it's a Big Ten university or something like that, and they're going to be hosting large swim meets. So because we're a custom manufacturer, we custom design the system for those specific applications, and we take those things into account. Who's the maintenance staff? Who's going to be working on it? The benefit of simplicity, energy efficiency, all of those things are the miscellaneous things that you want to keep in mind. So what is the conventional approach? Really, it was a focus on satisfying the dehumidification load through mechanical cooling, right? You dehumidify the pool air by running it through a cooling coil. Then you've got to reheat it, or you can reject the heat to an air-cooled condenser, or, and this is really the major benefit of the conventional mechanical dehumidifier approach, you can take that heat of rejection from the refrigeration process, and you can re-inject that back into the pool water. So that's kind of the flagship energy efficiency benefit of a mechanical dehumidifier is they say, well, hey, you've got this energy that you don't want to throw away. Why don't you reduce the heating load required on your pool water heater by taking it off the HVAC equipment. And it is an efficient solution. The single biggest drawback to this approach, though, is it only allows for the minimum ASHRAE prescribed amount of outside air. So if you have a situation where chloramines build up in the space, and that's not something as an engineer you can design for, it's not something as a rep that Long can prevent, or as a manufacturer that we can really do anything about. If an owner doesn't maintain the pool water chemistry properly and they run into a problem with chloramines, these mechanical dehumidifiers do not have the ability to introduce enough outside air in an efficient manner to offset that issue and clear it out. They can go through a shocking procedure, but that's not something that you can do every day of the week or every week of the year. It's something you can only do once in a while. And so that's the major drawback to their approach. So how is Innovent's approach different? We actually use outside air as our primary means of dehumidification. So from a mechanical efficiency standpoint, especially in a place like Salt Lake, right, where your design dew point day is a relatively low dew point temperature, we can use that low outdoor dew point to offset the space dew point and offset the dehumidification load primarily, right? We do some mechanical cooling because when it's not a design dew point day, but it's a design dry bulb day or the hottest day of the year in Salt Lake, you don't want to bring in so much outside air that you overheat the space, right? So we draw that back actually in the hottest parts of summer to less percentage of outside air, and then we sensible cool it so that what we're providing to the space is comfortable for the occupants. So our unit design is using a sensible aluminum plate heat exchanger to do airside energy recovery. And the two major benefits of that are you've got better indoor air quality because we're bringing in much more than the ASHRAE prescribed minimum, and we're running compressors a lot fewer hours than a mechanical dehumidifier would be. So operationally, it's more efficient as well. So it's kind of the best of both worlds. A hidden benefit of it is a custom product, and that custom nature allows you to fine tune the selection, like I said earlier, to fit that exact system, that exact design, that exact project. So we're using aluminum, which is a great material in pool projects. You want to avoid stainless steel if you can, and anything that we can't source out of an aluminum material, we put a protective coating on so that it can stand up to that environment as well. So in the situation where chloramines in a space get out of whack, our system is going to be able to offset that problem by bringing in an effective amount of outside air and making sure that the indoor air quality is good and that the space conditions are met. So this is kind of what the airflow diagram looks like. Pretty simple and straightforward. A little different than, maybe 100% outside air ERU, but you've got your outside air entering there in the upper left, coming through in summer. That's going to be about 50% of the nominal supply CFM that we bring in through heat recovery, right? That higher outside air dew point, we need our maximum amount of that to offset the dehumidification load. So we bring it in through the plate heat exchanger, and then we mix it with the remainder of the return air from the pool that's not exhausted out the other side of the heat exchanger. And if it needs to be tempered at all, we can, do a little trim with sensible cooling, get the supply condition to the right spot, and deliver it to the space. Now in winter, when your outside air dew point is much lower, we modulate back on that outside air amount. We close that outdoor air damper a little bit down to around 25% of nominal. That lower dew point, we need less of that air to dehumidify the space. And then so we're doing a little less heat recovery, but we're not throwing away all that energy from the pool. And that 25% is still an effective amount to maintain good indoor air quality in the colder months. From a pressure control standpoint, we're always maintaining that pool space at a slight negative. That's very important. With chloramine-laden air, you don't want that air leaking into adjacent party rooms or lobbies or things like that. You want air from adjacent spaces to leak into the pool room. So in conclusion, there's some specific things that you want to keep in mind, mostly indoor air quality, the risk associated with chloramines. The conventional approach to doing these types of systems, while it handles the space control, the temperature and the humidity, it kind of leaves the issues associated with chloramine buildup up to grabs, and it leaves it up to the owner. And if a problem occurs, it really doesn't leave you with any good options to alleviate that problem. Innovent's approach solves both of those problems. Not only is it an efficient solution, but it's utilizing that favorable condition of the outside air to do the dehumidification and to increase the amount of outside air that's in the space so that your indoor air quality stays in a good range. So I appreciate you guys taking the time to kind of walk through this with us. If you want more resources, we've got a section on our website called inventair.com/breathe. There's plenty of application guides, webinars, and just industry articles for you to reference there. And as always, feel free to reach out to your long sales point of contact, and I'm here to help you guys as well. So thanks again for your time. I'll pass it over to Destry here again.
Yeah, Jeff, thanks for doing that. We certainly appreciate all the information. And that concludes our presentation for the official 15-minute coffee break. Thank you for your time today. Reach out to your long sales engineer if you have any questions about Innovent, and we'll catch you on the coffee break next week. Thank you.